right, let's look at problem 69 from section 4.2. And we want to graph f of x equals natural log of x, and then use transformations of f of x to graph g of x, which is 6 log x. We want to graph and give the equation of the asymptote. So we want to use the graphs to determine the function's domain and range. All right, so we're going to start. If we click, we get a choice of graphing tools. Since we're graphing a logarithmic function, we pick the logarithmic graphing tool. And you can see the name, when I hover over this, the name pops up. And when I graph f of x equal natural log of x, when x is 1, y is 0. So once I pick that tool and I pick one point on that graph, and 1, 0 is the easiest point, then the curve automatically fills in. So now I have to determine what type of transformations I have. And I simply have a vertical stretch by a factor of 6. So this is 6 times the height of g of x is 6 times the height of f of x. So I go into the vertical stretching area and put in my factor of 6. If this were a vertical shrink, my c would have been between 0 and 1. Since my c was bigger than 1, I know it's a vertical stretch. And I know it's a vertical stretch also because the 6 is multiplied times the natural log of x. And so I simply can now click, and you can see that it actually stretched this. Now I'm also actually being asked to graph the asymptote as well. The problem should have actually stated that a little more clearly. So here's the line tool. So I select the line tool, and I know that the vertical asymptote is the asymptote is vertical, and it is the y-axis. So I can pick any 2 points on the y-axis once I select the line tool. Doesn't matter as long as they're both on the y-axis. And then I select dashing, because whenever I'm graphing an asymptote, I want it to be dashed. So that is the graph that I was being asked to provide. All right, now I want to give the equation of the vertical asymptote of g of x, which is the same as the vertical asymptote of f of x. And that is the y-axis, whose equation is x equal to 0. And now I want to give the domain in interval notation. So all positive, every point on this graph, and this extends forever in this direction, so I really could have an arrow here, and it extends forever in this direction. And notice my x's are only positive values. So this does not include 0. So I do parenthesis 0, but it does include all x values to the right of 0. So notice I use a parenthesis because the 0 is not included, and I always enclose an infinity symbol with a parenthesis because you can never be infinity. Okay, so that's my domain. Now the range are the y values of the points on the function. So the values of y that make up the y coordinate of the points on the function. And notice, if I extend this far enough, I get every positive y. I get y equal to 0 when x is 1. And I also get all negative y's. So this is actually all real numbers, or every possible real number serves as a y-coordinate for some point on this graph. So that is my range. Okay, and that is how I would work this problem.